All right, so let's get to work on our final method around the very basics at least. After this, we get to go on to traversal and searching and some of the more challenging stuff. And we have to worry about recursion and stuff like that. But for now, removing a vertex. So let's define our method. Come up here, we'll call remove vertex, and it takes in the name of a vertex like Hong Kong. And I've written a couple other method calls to build out a little bit larger graph so that we actually have some data to remove to make sure it all works. So if let's see, remove vertex, what do we need to start with? Well, as always, we're going to need to do this dot adjacency list of that vertex. And that's going to give us, for example, if we go back here, it's going to give us this if we're trying to remove Hong Kong. We need to loop over that. And for each item in there, we're then going to pass it in to remove edge. So let's do a loop right now. Let's just we could do while this dot adjacency list vertex, and I'm going to do dot length, which seems weird to do while this dot adjacency list dot length, but I'm going to actually pop off items from this list as we go. So eventually we'll get to 0 and then our loop will stop. You could do a for loop. You don't have to do it this way. So we're going to grab, let's just call it adjacent vertex. You don't even have to make a variable to do this, but to make it a bit easier to read, I'm going to do this here. So we're going to take each item and pop it. So here, if I run this right now, if we look at adjacency list, let's say we're looking at Hong Kong, we're looping over this while this whole thing has a length if we're trying to remove the Hong Kong vertex. First time through, pop this item, Los Angeles, off, and then we're going to call this dot remove edge. And what's the edge we're removing? Well, it's between Los Angeles and Hong Kong, the vertex itself. So the order doesn't matter. We can do vertex and then adjacent vertex, or we could do the other way around because this is an undirected graph. There is no direction. The order doesn't matter. We're removing both parts. Okay, so that will do that, takes care of that. And then if we actually run this now, and we look at G, let's do G dot adjacency list, just check on it one more time. All right, here's Hong Kong. Let's now remove vertex, Hong Kong. And if we look at the adjacency list again, you'll see, what do we have? Well, we got rid of all the references to Hong Kong. If we look up here, this is gone. And for example, there used to be Hong Kong in Dallas and in Los Angeles and Tokyo. And if we look at those, Tokyo, there's no Hong Kong. Los Angeles, no Hong Kong. Dallas, no Hong Kong. However, we still have this empty array. So this is where we need to delete that entire key. So down here, like I said, you may not do this very often. Delete this dot adjacency list of that vertex. So delete Hong Kong entirely. So if I rerun this, we look at the adjacency list again. It's back to Hong Kong. Now let's remove Hong Kong and look at the adjacency list again. There's no trace of it, hopefully. Yes, good, it's gone. Again, I don't know why we'd remove a flight or all flights to Hong Kong. Seems like that wouldn't happen. But you can see it's gone. Let's try removing Aspen now. And if we look at the adjacency list, no trace of Aspen either. Okay, so that's one way of writing remove vertex. There are other ways you could write that would be a little more efficient. Also, you could pretty easily add in some error handling, just add a conditional to make sure that the vertex is valid. But again, I'm keeping this very bare, minimal, just to focus on the logic. So next, now that we have our basic skeleton, we can add and remove vertices, edges. Now we're going to actually build out a little more complex graph and then talk about traversing and recursion and depth first and breadth first, and yeah, get your aspirin or Advil ready or alcohol or whatever you need. It's going to be quite the ride. No, it's fun stuff. Okay, that's next.